this video we will discuss about the problem Geek in a maze. So the problem says that Geek is in a maze of size n cross m. Each cell in the maze is either a dot or it's a hash. So if a particular cell is a dot, then that means that that cell is empty. If a particular cell is having the value hash, so that means that it is an obstacle, right? And you cannot move through that particular cell, right? And now the problem says that you will also be given a starting point in this cell, that is r comma c. So this grid is a zero based indexing grid, right? So the first cell is 0 0, then the next cell is 0 1, and like that the indexing is followed. So it says that you will be given a starting cell, let's say r comma c, and what you have to do is you can move at most, like in this you can move in 4 directions, right? You can either move towards the right direction, you can move towards the left direction, you can also move towards the down direction, and you can move towards the upward direction, right? You can move in all the 4 directions possible, but there is one constraint that you can move in the upward directions, right? In the upwards direction you can move at most u times, right? At most u times you can move in the upward direction, and at most d times you can move in the downward direction, right? So let's say suppose if there is some d value, right? Suppose the d value is, let's say, 3, right? So in that case you can move in the down direction only 3 times, right? And it can be like this, or it can be like this, let's say this, then you, let's say, move up, then let's say you move this, then down, and then down, and then down, right? So here the 3 count is done, right? So you can move in the downward directions only 3 times, right? After that you cannot move through that. So basically what you can do is you can move at some number of times in the upward direction and some number of times in the downward direction only, and you have to tell that what is the maximum number of cells, empty cells, that you can reach. Okay, let's see this problem statement. So the problem says that you have to find how many different empty cells you can pass through while avoiding the obstacles, right? And you can move in the all 4 directions. Only the constraint is that you can move up at most u times, and you can move in the downwards directions only at most d times, right? So let's suppose that this is the test case that has been given to you. So in this test case you can observe that there is a dot that is empty cell, and this particular cell and this particular cell are what? They are cells which are filled. They are filled with obstacles, right? So basically in this particular problem what you will be given is, you will be given the starting cell is this, right? Suppose that this is your starting cell. So the very first thing is that, let's say there is a matrix, and the matrix of R and C is given to you, right? Let's say matrix of R and C has been given to you. So you can easily observe that if the starting cell, right, if the starting cell that has been given to you, if it's equal to a hash, right, if it's equal to hash, then you will say that you cannot make any movements, right? No movement would be possible in that case, right? So that in that case you will return a 0 simply. But if it's not a dot, right, if it's not a hash, so if it's not an obstacle, if it is a dot, right, so in that case you can move through that cell, right? So once you have moved through that cell, right, so you can maybe mark it as 1, right? Let's say you were at a current cell, let's say matrix of I comma j, right? Let's say suppose that you were at a current cell that was I comma j, right? Its index was I comma j. So what you can do is, let's say it was a dot, right? So once you have moved through it, so you don't want, let's say what happens is let's say there is a grid and the situation is like this. Let's say dot, let's say empty space, empty, right? So let's say you start iterating from this particular cell, you move towards the right direction, then you move towards the right direction once again, then you move down, then you move like towards the left direction, then you move left again, and then you move up again, right? So in that case maybe you can count it more number of times, right? Let's say you move like this again. So in that case what can happen is, and let's say you move down from here, right? So in that case maybe you can count some of the cells that you have already visited many number of times instead of counting them one time only. So that's why what you can do is, if you have moved through a particular cell, right, so you will mark it as 1, right? The moment you move through a particular cell, so you can mark it as visited or mark it as 1. So that what happens is, let's say you move here, then you move here. So the count ultimately up till here is what? 6. And then when you move to this direction, so whenever you move through a cell, so you mark it as 1, right? So you will be only moving to those cells that are valid and that are empty cells, right? So that's how the concept is gonna look like. Now what you can do is, you can simply use a breadth first search, right? You can implement this particular question easily using a breadth first search, right? So you can maybe do what? You can first of all see that, let's suppose that you are at a current cell, let's say I x comma y, right? Suppose that you are at a current cell x comma y. So suppose that first of all what you try to do is, suppose that you push this particular cell into the queue, right? But at every cell, whenever you are at a particular cell, right? So let's say you are in a grid, and let's say you are at a particular cell, right? Let's say you are at a particular cell. So what you need to know is, you need to know that, okay, what are the dimensions of the cell, that is what is the x coordinate, what is the y coordinate. Apart from this, you also need to know that how many when you have reached this particular cell, so how many number of up movements you have already done, how many number of movements you have already done in the upward direction, and how many number of movements you have already done in the downward direction, right? This is something that you already need to know, because if the number of upward directions is lesser than the maximum number of upward movements that you can take, and if the number of downward movements that you have taken, if it is lesser than the d that has been given to you, that is the maximum number of downward movements that you can do, in that case only you can move further, right? In that case only, from this particular cell you can try to move, let's say, down or up, right? So that will depend on the constraint, right? So there is one more parameter that you should do. So that's why what you will do is, you will definitely use a BFS, and for BFS you use a data structure that is known as a queue data structure, right? That is first in, first out. After this part, like in a queue, right, when you are declaring a queue, so your queue will behave like a vector, okay? Your queue is gonna behave like a list or a vector. Why will it behave like so? Because in this, what will happen, it will behave like a vector because it will have four things. First of all, it will have the x coordinate of the current cell, it will have the y coordinate, it will have the u up, that is the number of upward movements that you have done up till this particular cell, and it will also have the detail of the downward movement, right? That is the number of downward movements that you have done up till this particular cell, right? So these informations you will have, and according to them you will be moving, right? And you will also have a counter. And as I mentioned that, like, let's say you move from this particular cell, right? So let's say you push this particular cell, right? Let's say you push this particular cell, right? And the this particular cell you push, right? So this particular cell is empty, right? So you'll mark your count as what? You'll mark your count as 1. So you'll say that you have visited this cell, so you'll mark it as 1, right? Instead of a dot, you will say that, okay, now I mark it as 1. So you will say, instead of a dot, I will mark it as 1. Then what happens? Let's say you move in the upward direction, right? The moment you move in the upward, or let's say you try to move first of all in the left direction. So is the left direction possible for this particular cell? No, a left movement is not possible because it becomes invalid. The grid is not possible towards the left, right? Because this is the leftmost cell, right? So you cannot move towards the left direction. So let's say now what you do is you move towards the direction that is the right direction. Can you move towards the right direction? No, you cannot, because there is an obstacle present, right? So you will try to move, then after that you will try to move towards the up direction from this particular cell. And from this particular cell, when you try to move towards the up direction, can you move towards the upward direction? Yes, you can move towards the upward direction, right? So when you are moving towards the upward direction, right? So what you will say is that, can you move? Yes, you can definitely move towards the upward direction. So you'll say that, okay, you will mark your counter as 2. But at the same time, what you will do is you will pass the indexes. So this is what 0 0, right? The starting index was what? The starting index in the queue was nothing but 1, and then what? 1 0 and 0 0, right? That is the upward movements, and the downward movements were 0. But when you move towards the upward direction, right? So one upward movement is wasted, or one upward movement is used. So you'll mark your up as 1 and down as 0, right? And after this, like, let's suppose that there was another cell above it, let's say there was another dot, so you cannot make an upward movement furthermore, because what will happen, your up is already 1, your upward movements is already 1, total number of upward movement till the cell is already 1, and you cannot move up again because your up should be lesser than the maximum number of ups that you have done, right? So that's why. Alright, so this will be the case. So let's say you are at this particular cell, right? So from this cell, if you would try to move towards the left, so you cannot move towards the left because it is an invalid cell, it's going out of bound. Then let's say you try to move towards the right direction, and you will move towards the right direction, right? And also one more thing, as you know, in a queue, what you do is, this particular cell, you will try to move it out, right? You will try to pop out this particular cell from your queue, right? You will move this particular details, you will move this particular node from the queue, right? After this, what will happen? You will insert this queue, right, into the queue, and your count will change to 3, right? After that, you will try to move in the leftward direction, but first of all, you will mark this as 1, right? You will mark this particular dot now as 1. Why you will mark this particular dot as 1? Because you don't want to visit the cells again and again, right? You will mark this as 1 again, and the count is 3, right? After that, if you try to move towards the left direction, you cannot move towards the left direction, right? Because it's already marked as 1, right? It's not a dot, it's not an empty space. After that, if you try to move towards the down direction, you cannot. If you try to move towards the up direction, you cannot, right? It's not valid. So you'll try to move towards the right direction, and you can see that you can move. So you'll mark your count as 4, right? Your count gets to 4. right? And up till now you can observe that the cell values will be changing, but like cell value is this particular cell will be what 0,3 and then what 1,0, right? Because upward and downward movements have not changed, right? After this part is done, like it will be what, it will be nothing but 0, 3 and 1 and 0, right? After this, let's say you move down. The moment you move down, so what happens is, first of all you'll mark this as 1, and let's say you move down, right? Because upward movement will not be possible, left movement is not possible, and right movement is not possible from this cell, so you'll move down. Let's say you move down, so the moment you move down, so what happens is your cell value, this particular cell is what, it will be nothing but 1, like it is the row number 1 and it is column number column 2, right, according to the zero based indexing. And then what is happening, upward direction is 1 and downward direction is also 1. So you'll mark this because upward and downward, total number of upward that you can do is 1 and downward directions that you can move is also 1. So that's why you'll mark it as 1 and you'll say that okay, counter increases to 1 more and counter changes from 4 to 5, right? So earlier, like as I said, the counter was earlier 2, then it changed to 3, then from 3 it changed to 4, and now it changed to 5, right? Now from this particular cell, can I move to this upward direction? No, I cannot. Can I move to left direction? No, it's an obstacle. Can I move towards the right direction? No, I cannot. Can I move towards the down direction? Down direction is empty. Maybe I can, but the thing is that this particular cell is having information it is having the information as 1, 2 is the cell x and y, the x axis and y axis, and then 1 and 1, right? Notice the upward movement and the downward movement. You have exhausted your upward and downward movements both, right? So you want to move down, right? You want to move down, but actually you have already used the maximum number of down movements that you could have done, that is 1. And if you move down, so your down will change to 2, but you cannot make more than 1 movement towards the down direction. So that's why you'll not add this particular cell, right? So that's why the total number of cells that you will be visiting will be what? This particular cell you will be visiting, this cell, that is 2, 3, 4 and 5. So total 5 cells you will be visiting, and this cell will remain unvisited. So that's why this cell and this cell you will not be able to visit. So that's why total 5 cells you will be able to visit that were empty, although there were total 7 cells that were empty, right? But you will be able to visit only 5 cells. So that's how you are going to implement this particular question using the queue, that is queue data structure. Let's try and quickly implement the code for this particular logic. So what I'll be having is, first of all I'll be declaring a queue, right? So I'll be having a, let's say, queue of what vector, right? And this particular question has been asked. One more thing that I would like you to notice is that this particular question has been asked in top product based companies, like it has been asked in Amazon and Microsoft, right? Let's quickly code down this particular problem and see if we can get it as accepted or not, right? So I'll have a vector of int like q, right? And what I'll be doing is, I'll be, first of all, before declaring this, right, I need to check that if the matrix, right, if the matrix mat is the matrix that has been given to me. So if matrix of r comma c, right, if the starting cell that I have been given, if it's equal to a hash, right, if the starting cell is a hash, if it's blocked, then I'll definitely return a 0 because no movement is possible, right? After that I'll declare a queue, right? And in that particular queue, what I'll be doing is, I'll be pushing this particular vector, right? I'll be pushing what? I'll be pushing the starting row, that is starting row is what? R, and the starting cell is C, and then 0 is the number of upwards movement that I've done, and 0 is the number of downward movements that I have done, right? After that what I'll do is, I'll say that okay, this particular cell I'll need to mark it as 1, right? Since the matrix is a character based matrix, so I'll mark it as 1 in terms of a character and not in terms of integer, right? After that what I'll say is, I'll say that okay, my count becomes 1 now, right? I'll mark my count as 1 and I'll run my BFS, so that is while not of queue.empty, until and unless my queue is empty, until and unless all the nodes are exhausted in the queue, I'll be running, okay? And what I'll do is, I'll say that int let's say row is the current row, right? So what I'll do is, row is equal to what? Queue.front, right? Queue.front is giving me what? Queue.front will give me nothing but the front node of the queue, right? And I need to do what? Queue.front is a vector itself. So queue.front of 0 will give me what? The row number, and I'll say int call is equal to what? Call is equal to nothing but queue.front of nothing but what? Queue.front 1, that means the row. That means the column, right? And after this I'll also need to have the up, so the number of upward movement that I've done is nothing but q what? Q.front and 2 right, because that is the number of upward movements that I must have done, right? I'll write it as up. And after this is done, so what I'll do is, I'll say that int down movements, the number of down movements that I've done is nothing but q.front and what? 3. This is because according to that it will tell me, right? Because the first value will tell me about the row value, second value will tell me about the column value, third value will tell me the number of upward movements that I've done, and fourth value will tell me about the number of downward movements that I've done up till this particular cell, right? After that I'll pop out the current cell, right? As I told you, I'll pop out the current cell from the queue, right? And what I'll do is I'll try to check in all the directions, right? So first of all, maybe I can try to go towards the left direction. So if I want to go towards the particular cell, right? So the first thing is that particular cell should be empty, right? So I'll say that maybe what matrix of row and column -1, because if I'm moving towards the left side, okay? So let's say if you are here, right? Let's try and understand this part as well. So let's say if you are in a current row comma column setup, right? Let's say if instead of this, what I do is I mark it in terms of numbers. So let's say you are at a current cell, let's say this cell, and this cell is what, let's say this is R comma C, right? So if you want to move towards the left direction, okay, so the row remains the same, but the column decreases by 1, because this is column, so this is column -1. So the identity of this particular row moving towards the left will be what, R comma C -1, right? So that's why row will remain the same and column will change. So that's why what I'll do is I'll do this part, right? I'll check if it is equal to a dot, right? If it's equal to empty, if it's an empty cell, right? But I also need to check that whether this particular cell is existing or not, right? Because what happens is this particular cell will exist, right? This particular cell will definitely exist. But suppose that this was your R comma C, right? Suppose that this was your R comma C. In that case, what happens is a C -1 existing? No, because R comma C -1 is out of bound. So that's something that I need to check, whether the column is greater or equal to 0 or not if I'm subtracting it by 1. So according to the zero based indexing, I'll check that whether if the column -1, if the column value -1 is greater or equal to 0, and it happens that matrix of row and column -1, like if moving towards the left direction, okay, if I'm moving leftwards, if I'm moving toward the left direction, right? If I'm moving towards the left direction, so if it happens that if it's valid and it is empty, right? If it is empty, so in that case what I'll say is I'll say that okay, I need to push this particular cell into my queue, so I'll push it with its information, that is row and the column -1, right? Column -1 is its identity, and the number of upward and the downward movements remain the same, right? After this part is done, so I'll say that I need to do a count plus because this will change, right? And I also need to do one more thing, that I'll say that matrix of row and column, I'll mark it as what, column -1, that is the next row that I'm moving to, I'll mark it as 1, right? Because I've already like I have visited it, I'll mark it as visited, right? After that I'll say that if let's say that I want to move towards the right direction, okay, so if I want to move towards the right direction, so suppose that I am currently in a row, right? I'm currently, let's suppose, in a setup, and let's say I'm currently R comma C, right? So if I want to move towards the right direction, that means the row remains the same, but the column changes by 1. So R comma C plus 1, right? So this will be the thing. But I also need to check that if suppose that this was my R comma C, right? So if I move towards the right, so it will be invalid, right? So I need to check whether column +1 is lesser than n or not. Okay, that is some lesser than m or not, right? So if column +1 is gonna be lesser than m, and so that it's valid. And I also need to check that if matrix of row and column -1, right? If matrix of row column -1, right? Column +1, if it's an empty cell, right? If the cell is an empty one, if the cell is empty, right? So that means that we are trying to move towards the left direction, okay, right direction, sorry. So that means that we can move towards the right direction, we can move towards the right cell because it's an empty cell and it's valid. So in that case, what I'll do is I'll say that I need to do what? I need to do q.push, nothing but I'll push the row and I'll push the column +1, right? And what I'll do is I'll say that up and down will remain the same because I haven't done any up and down movements for this because I'm moving towards the right direction, okay? And I'll definitely do a count plus after this. And what I'll do is I'll mark this particular cell, that is the right cell, as visited, right? Because I have currently visited it. So I'll say that since I've put it into the queue, so I'll mark it as visited. So I'll say that row column +1 is equal to 1, right? So that is something that I'll do. After this part is done, so I need to move towards the upward direction as well. So if I want to move towards the upward direction, right? So let me see, if let's say I was here, right? Let's say I was at this particular cell. Let's say I mark this particular cell. Suppose that I was at this particular cell R comma C. So if I want to move up, so that means the row changes by 1. If this will be row R and R -1. So R -1 and the column remains the same. So R -1 comma C, right? So that is something that I'll be doing, and I'll be checking whether it's valid or not. So I'll check that if row is row minus 1 is going to be greater or equal to 0, right? If it's greater or equal to 0, right? And I also need to check if the upward number of upward movements that I have already done, if it's lesser than the u that's been given to me, right? If it is lesser than the u number of movements, u number of at most upward movements that I have done, so if it is lesser than that, right, and this particular matrix, right, if this particular matrix of what, if this particular matrix of, let's say, row minus 1 and column, right, if it's equal to an empty cell, if it's an empty cell, right, so in that case I will push it, right? So I'll say that I need to do what, I need to do q dot push nothing but row and comma column plus row plus 1, row minus 1, okay, comma column comma what, up u up plus 1, because I'm doing one movement in the upward direction, so I'll change the upward by 1, right? I'll increment it by 1, and then down remains the same, right? So in this way what I'm doing is basically I'm moving towards the up direction, okay, up direction I'm moving towards, right? After this part is done, so I'll say count plus plus, and I'll need to say that matrix of what, row minus 1, right, row minus 1 and column will get incremented, will get changed to 1, that is, it will be marked as nothing but visited, right? After this I need to move in one more direction, that is the downwards direction. In that case the row will increment by 1, so row plus 1. So I'll check whether row plus 1 is lesser than n value or not. If it is lesser, so I need to check, if since I'm moving down, so I need to check whether the number of downward movements that I have already done, downward directions movements that I have already done, if it is lesser than d, right, if it is lesser than d, and I need to check that whether this particular cell is empty or not. So I need to check that if matrix of what, if matrix of row plus 1 and column, if it's equal to empty, right, if it's an empty cell, in that case I will say that okay, I can move in the downward direction, okay. So if I can move in the downward direction, so I'll say that q dot push what, I'll push nothing but row plus 1, okay, I'll push row plus 1 comma column, right, and I'll upward movements will remain the same and downward movements will increase by 1, okay. After this part is done, right, after this part is done, so I'll do a count plus plus simply because indicating that there is one more cell that I have visited, right. So I'll say that count plus plus, and since I don't want to visit it again, or I don't want myself to be stuck in an infinite loop, so that's why I'll say that I have visited this row particular cell, right. So I'll say that I've visited row plus 1 and column, and I'll mark it as 1, right. So that is what I'll be doing, and in the end, right, after this part is done, so I need to simply return the count of the unique cells that I visited. Let's quickly try and compile this code and see if it has any compilation issues. So it seems to work on the samples. You can see that we are getting the output 5 as expected for the sample test case. Let's quickly submit this problem as well. So you can see that this particular problem was able to pass, this particular solution was able to pass all the 201 test cases. So that is how you do this particular problem, right? So I'll quickly walk you through it, that if it happens that the current, the cell that has been given to you, the starting cell is obstacle, so you'll return 0. Otherwise what you will do is in the queue you will have a queue that will behave like a vector, because you need to have the row information, the cell information, row information, column information, and you need to know how many number of upward movement you have done, how many number of downward movement you have done. For the first cell you will push the row column and 0 0, and you will mark your matrix as 1, indicating that that particular cell you have visited, the starting cell you have visited. Then you will mark your count as 1, and what you will do is you will simply have this queue, and you will be running in all the 4 directions with the row column upward downward, and you will be popping out the current and you will be checking if it's valid. If you can move in left direction, so you will add it and you will mark it as visited as well. You will increment the count, and similarly you will do for every particular cell, right? That's what you're going to do, and in the end you will simply return the count, right? So that's how you can do this particular question. And before ending this thing, so I'll like to say that this particular problem can be asked in a lot of organizations, and they can also put a constraint that the number of right movements that you can have, or the number of left movements that you can have, they can also put a constraint on these things. And these questions are frequently asked in companies like Amazon, right, and Microsoft, and you can say maybe it can be asked in a company like Google, Adobe, and others, right? Thanks a lot for watching.